guys, it's Bakara and this is my crib. Come see my friend.
Oh, you're here!
Seda.
Hi!
Say hi to the vlog. Sheila and Alyssa also. Say hi to the vlog.
Hi guys!
And Sophia and John. Say hi, please. So the topics that we are going to discuss is the significant figures and scientific notation. What are the last two topics again?
Oh, it's accuracy and precision in Dalton's atomic theory.
So let's begin.
Hello guys, our first topic for this video is significant figures. Significant figure. It is a calculated quantity that indicates the margin of error of meaningful figures. In significant figures, we also have rules to follow. The first rule is all non-zero digits are significant. For the second rule, all zeros between two non-zero digits are significant. Third rule is, if the number is greater than 1, all zeros to the right of the decimal point is significant. This indicates decimal point placements. Rule number 4, case 1. If the number is greater than 1, then the zeros to the right is significant. Rule number 4, case 2. If the number is less than 1, then the only zeros at the end of the non-zero number and between is significant. Lastly, for the number that does not contain decimal points, trailing zeros may or may not be significant. To remove ambiguity, use the scientific notation. Let's try to calculate and solve significant figures. In addition, all you need to remember is to round off the number to the last number of decimal places in the equation. In subtraction, all you need to remember is to round off the number to the least number of decimal places in the equation so that the number of decimal places will match the number of decimal places on the answer. In multiplication, you have to match the number of significant figures of the answer to the least number of significant figure used in the equation. And lastly, you have to match the number of significant figures of the answer to the least number of significant figures used in the equation in division. Thank you for watching. Sit tight, the next lesson is up ahead.
Our new lesson for today is all about scientific notation. So what is scientific notation? Scientific notation is a way of expressing numbers that are too big or too small to be conveniently written in decimal form. In scientific notation, the digit term indicates the number of significant figures. The exponential term only places the decimal point. So now we're going to teach you how to convert decimal to scientific notation. Let's go to the basics of scientific notation. Up first, the coefficient must be between 1 and 10. The exponent can be positive or negative, but it must be an integer, and 10 is the base. Move decimal to the right or to left to arrange one digit to the left of the decimal point. Example number 1. The given is 530,000. To obtain one digit to the left, you must move it 5 times to the left to achieve the answer of 5.3 times 10 raised to 5. Example number 2. The given is 0.00231. To obtain a non-zero digit, you must move it to the right 3 times to get an answer of 2.31 times 10 raised to negative 3. Always remember, if you move the decimal to the left, the exponent will be positive. And if you move the decimal to the right, you will have a negative exponent. Hooray! Our lesson is finished. Now, it is your turn to solve these problems. Now, check your answers. Congratulations! You have answered it correctly. You did it! Let's talk about accuracy and precision. Accuracy refers to the closeness of a measured value to a standard or known value. If the average of their values are close to the true value of the quantity being measured, it is accurate. Precision refers to the closeness of a measured value to a standard or known value. The set can be said to be precise if the values are close to each other. This target board shows the differences between accuracy and precision. Example, there are 3 students, student A, B, and C. Their average weight was computed. Student A weighs 1.971 grams, student B is 1.970 grams, and student C is 2.00 grams, and the standard value was 2 grams. The results were given. Student A weight is precise, same goes to student B, and lastly, student C's weight is accurate.
Dalton's atomic theory. There are 4 theories involved in Dalton's atomic theory. First theory is all matter is made up of completely small particles called atoms. Second theory, all atoms of a given element are identical. Third theory, compounds are formed when atoms of different elements combined in fixed proportions. Fourth theory, a chemical reaction involves a rearrangement of atoms, not a change in the atoms themselves.
Thank you for watching our video, guys.
If you learned something, give our video a thumbs up.
If you have comments or thoughts, comment down below.
And don't forget to
Subscribe!
Bye!